So traditionally in woodshop class, I don't know how many people here took woodshop going through school or whatever, but this is one of the typical things you see done in a woodshop class. We're going to design a CO2-powered car, and we're going to race them as a class against each other, and we'll have some silly little plaque that we made on the drill press, and we'll give it to whoever has the fastest car. So you typically take a design, and it might be a paper design. In my woodshop class, they had an archaic piece of software from 1960s that barely did the job. It did have some aerodynamic modeling stuff, but as I found out, I got a little complicated with it, and the computational model didn't match the physical model in terms of how the aerodynamics work. I lost that competition horribly. You have to go and get pieces of wood. You have to get a raw material, and then on a variety of dangerous, difficult to use machines that are frankly dirty and noisy and so on and so forth, after a few days of work, you finally have your finished product and you can go off to the races with it, right? In Woodshop 2.0, the basic parts of the process are the same. I have to start with a design file of some sort, but in this case, because it's digital fabrication, it has to be a digital design file. It has to be something that I can put into my computer and have it understand this is the thing I want you to make, right? So you do all your design work, so on and so forth. You get a roll of, this is a blue filament there. You get a 3D printer, you put it all together, and out comes a car. That's actually a open source rubber band powered race car that you can find on thingiverse.com. By the way, all the models and examples you see in this that are from the fabrication space are open source. You could absolutely go out today, download it, print it out. Let's talk about some other areas of the education space where this might be applicable. Mathematics and physics. Physics experiments can be directly created in plastic. You want to demonstrate period of a pendulum? You can create 3 different pendulums with different lengths and give it to the students and have them actually run an experiment on that. Concepts such as leverage, mechanical linkage, and momentum transfer very easily to a 3D printed object. It's really limited only by the teacher and the student's collective ability to transfer thought experiments into physical objects. Anyone here who's been to or taken or teaches physics knows that physics is full of thought experiments. Things that if the world were frictionless and gravity didn't exist and blah, 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 this is what would happen. But the real world always gets in the way. So really it's a kind of challenge for how do I design so that I show the concept without letting the real world get in the way. Mathematics instruction likewise can be greatly enhanced. You see there's 3 objects on that from various design software and a real object of subsurface modeling. Basically, I have a function and I want to plot what the output of that function is in 3 dimensions. It takes x and y as an input and it gives me z as the output. This way, when you're talking about complicated subjects such as hyperboloids, you can actually print one out and hand it to your students and say, this is what we're talking about. Most high school math instruction stops at 2 dimensions because it's hard for students to visualize that 3rd dimension. It's much easier to talk about the functions in x and we'll graph along the y-axis rather than let's create a physical object out of this function. That's not a technology that they have right now. We could absolutely add that to mathematics instruction and create much smarter students out of high school with this technology. You can illustrate complicated 3D concepts such as manifolds, integration, and geometry. And of course, interactively, students could actually create objects that are solutions to problems. I want you to go and create the sombrero function in a physical piece of plastic, for instance. Chemistry class benefits greatly from open hardware. All sorts of lab apparatus that won't be in direct contact with chemicals or reagents are possible. Test tube racks, ring clamps, that sort of thing. Molecular models are likewise very easy to create. And of course, materials research. If you have a MakerBot, you can make all sorts of materials with it, test them out quickly, create prototypes, go through the iterations that would typically be involved in a research program right there with your students. In the biology and biochemistry space, there's this great project called DIY Bio. Has anyone heard of it? No one. So you can go to their website at diybio.org, and they're all about creating tools and technologies to help in the home bio lab setup. They have PCR boats for doing DNA analysis. They have centrifuges that you can print out and mount to your Dremel and spin down cell samples with. They have, you see the thing on the right there, that's an orbital shaker. Again, it's used in biology for cell culturing and incubation experiments. Beyond the DIY bio, this is like typical labware, right? We could all go down to a manufacturer and buy the same thing. The only real advantage is I'm making it in my lab on my own time. I get it when I need it, right? But beyond that, you can create microfluidic lab-on-a-chip designs. These designs can do such things as cell cloning, sorting, and incubating. So you can create your own sort of little mini biolab on a chip with MakerBot technology. You can also create models of cells and tissue. So that on the bottom left is the human, I'm not sure I'm saying this, ossicles. It's the bones in the ear. That's from some Stanford open scan data. Stanford did a CT scan of a volunteer back in the 60s, and they open sourced the actual scan data so anyone can go and download it, and they sliced it up so you can get just the arteries or just the bones, or all sorts of useful permutations of that. Oh, and if you didn't recognize it, that's, of course, DNA on the top right. Great for the desktop ornamentation, right? Robotics. Anyone here involved in FIRST? I've heard a few people, mention FIRST while we've been here. Robotics is absolutely an area where the MakerBot seems to be made for. These are 3 different, again, open source designs. You could go out to thingiverse.com right now, get these designs. We could start printing them out over in our booth. Gearing and cam structures, the actual chassis, the structural components, pretty much anything that doesn't involve a motor or electronics is possible with a MakerBot. You even see on the bottom left, those are Mccracken wheels. They're multi-directional wheels. If you turn them in different ratios, the bot doesn't have to go just forward. It can go sideways, backwards, whatever. Cutting edge research is done on 3D printers every day. I just want to talk about these 2 projects. Again, these are both on thingiverse.com. You can go download them and print them out and experiment with it yourself. On the top left, that's the biotransistor by Mr. Kim. His website's on the slide. That's an actual printable inverter circuit made of biological transistors, organic transistor technology. So he went and found a company that was willing to source him a small amount of the fluids needed for that. He put them into his MakerBot in a pin plotter, and he literally drew the circuits on a sheet of plastic and created an inverter circuit at home. He didn't have a clean room, he didn't have a vacuum, he just printed it out on a sheet of plastic and it worked. The other thing there is a thermotype PCR block. You see these things in CSI all the time. It's that machine that has all those fingers and it goes like this and it goes in the machine and they get like the DNA results and they go out and catch the criminal, right? Where can I go for more information on the topic? There's a lot of great websites out there. I listed just a few of them here. reprap.org is the site that hosts the design files for this machine. It also has a lot of designs for things called rep straps, which is basically, I want this technology, but I don't have a 3D printer. How can I get there with traditional tools and technologies? I have a drill press, I have a table saw, I have a bunch of wood. What can I do to create a 3D printer out of this? Thingiverse.com, I've mentioned it quite a few times. There's 7,000 designs out there. 10 or 20 are uploaded every day. It's really a great site. If you're at all interested in 3D printing, even if you don't have a 3D printer, I strongly encourage you to go out there, surf it, check out what's available out there. You'll be pleasantly surprised, I'm quite certain. I didn't give a lot of lip service to Arduino, but Arduino is the open source hardware platform on which the firmware for MakerBots and RepRaps run. This is actually an Arduino board running the whole thing. Arduino.cc is their website. I don't know if you've been out there. Not a lot of activity happens on there, but there is a good library and reference for how to program and how to get the tools you need to upload code onto the chips. I don't know if you guys read MakeSign. They often feature articles on 3D printing. I don't think there's been an issue out in the last year that didn't have at least a half-page article on some aspect of 3D printing. Lots of do-it-yourself sites are findable through Google that have instructions on 3D printing, information about what people are doing with 3D printing. I'm just going to mention a couple of the websites I know of, Instructables.com and Hackaday, very frequently have 3D printing articles on them. And at the bottom there, fablocker.org, that's my hometown's hackerspace. We post all sorts of blogs and videos and pictures of what we're doing and what we're up to and the kinds of tools and technologies we're interested in getting in the future. Definitely check it out, especially if you're in the, especially if you're in the Winston-Salem, North Carolina area. Please come by and attend one of our meetings. We'd love to have you. That's it for the prepared content. Does anyone have any questions?
Since those use thermoplastics, they can only be heated once, is that correct?
Well, there are different kinds of thermoplastics. That's a good point. So you're probably familiar with polycarbonate, which is like the traditional thermoplastic. And for those who don't know, we call these shrinky dinks typically, right? Shrinky dink is an excellent example of I have something and I'm going to modify it and I'm going to bake it, and when it's done I can't really go back to the original form because I don't have the machinery that the shrinky dink company used to roll it out and anodize it in the first place. This plastic, we typically print with, there's two main plastics and a handful of other engineering type plastics we use. Any thermoplastic you can print with, absolutely. So if you know an engineering firm, if you know a plastics firm and they have some experimental that you want to use out, they just have to roll you out a 3mm filament you can stick in your machine.